this closer. All right. There goes that. Good morning, everybody. All right, tablet is deciding to connect. It's behaving today. That's a good sign. Okay, so today we're going to start what is undoubtedly the most important topic of the course, which is on unit conversion, or also called dimensional analysis. It's a fancy term, but they both mean the same thing. It's something that you already know how to do, but we're just going to make it a little bit more formalized, and we're gonna help you kind of understand that this kind of method, kind of doing it more formally, will allow you to apply it to a whole different array of units. And I mean, if we were to just start with something again that you already know how to do, we could say, okay, how many seconds are in a year? All right, and then we're just going to say, like, assume 365 days, just in case of leap year problems and all that. We can calculate this. I mean, you already know how to calculate it, or at least you'll have some idea, right? And so kind of in your brain, you'll be like, okay, well, we have 1 year, right, that we're starting with. And we're going to do kind of multiple things here that's going to end up giving us seconds. Which is abbreviated S, by the way. And so we might be like, okay, well, a year is really long, a second is really short. There's some units in between here that we know. I put a bunch of arrows there, but I may or may not have the right number. We know, a year, we can convert that to days. And days, we can convert into hours. Hours into minutes. And then those we can convert to seconds, right? Something that, you would be able to do, you'd be like, okay, well, I know there's 60 seconds in a minute. I know there's 60 minutes in an hour, 24 hours in a day, 365 days in a year, right? So we could, we already know what are called conversion factors going between these. But I want to just point out a couple of things here that this idea of kind of planning out our route for coming up with our unit that I'm asking for seconds in this case. This is what's called a unit plan. And we're going to see that, for time units, we're already completely aware of all the different time units, right? And we already, in fact, know the conversions in between them. But, again, if you want to be very formal about it, you'll write out your unit plan each time. As you get more and more practice with it, you'll find, maybe you don't need to. But it's, especially when you're just starting out, it's a good idea to do it for each problem. So, and I think you'll see on the worksheets that it's going to ask you for unit plans. So that's what a unit plan is. It's just showing which units you're going to be going through to get from what you're starting with to what you're ending with. So that's the idea of a unit plan here. And we're going to see that kind of each arrow in the plan is one conversion factor. So we should define what a conversion factor is. A conversion factor is essentially an equality between two units. for example, 1 year is equal to 365 days. That's inequality, right? They are equivalent to each other. Same thing, but different units. And this is called a conversion factor. And again, I've turned yellow. I don't know why it does that. It's just really curious to me. Like, for some reason, like, there's just not enough sunlight, and my regular light is kind of yellow, I guess. So, who knows? And now I'm back to normal. So, whatever. These are called conversion factors. All right, and so as we are going to approach this idea of unit conversion, we'll be using these conversion factors to go through the process. So since we already know all of these conversion factors, let's go ahead and write them all out. So we saw that this kind of number 1 here, that was the conversion between years and days. We know also the remaining conversion factors that we're going to need. Again, these ones you already know, but as we go forward, maybe you're not going to know them, and we'll see what to do in that case. So either you'll be given them, by the way, or it's something you will have to know. So that's the short answer. Okay. Our second conversion factor is between days and hours. So we already know that 24 hours is equal to 1 day. Our next conversion factor was between hours and minutes. So we know that 1 hour is equal to 60 minutes. And our last conversion factor, we know 1 minute is 60 seconds. So, stuff we know. So far so good, hopefully. Things, again, we already know. But these are the 4 conversion factors we're going to use in going from years to seconds. All right? And just for sig fig purposes, I'm going to just go ahead and change this to like 1 year with 3 zeros on it. So just to give us some sig figs at the end. We don't want to just have 1 sig fig at the end. So we'll talk about sig figs as we go through this. Thankfully for us, okay, well I can kind of do this, I guess. All of these conversion factors are definitions. They're defined, right? We define 1 year as 365 days. Although in reality, well, okay, never mind. We'll leave it at that. We define 1 hour as 60 minutes, right? These are definitions. And as a result, if things are defined, they are not measurements. No one is measuring 1 hour and measuring 60 minutes and finding they're the same. They're not measurements, they're definitions. And as a result, we don't have to worry about sig figs with conversion factors that are definitions. So you see here, we have the 1 hour and 60 minutes are, if we were to just look at the numbers, we'd say, oh, they might be 1 sig fig. But because those are defined, we're not going to have to worry about the sig figs for them. So as we go through this process of using these conversion factors, we can ignore the sig figs that are represented within that conversion factor. And we're going to see what that looks like. The rule of thumb is essentially take a look at the sig figs of your starting number, 1.000, and you're going to generally end with the same number of sig figs. Because we're going to see we're just going to be doing multiplication division with these. So let's go ahead and see what this is going to look like. Yay, no sig figs for those numbers. All right, so how this works is we're essentially going to be using these conversion factors as fractions. And the beauty about this is since 1 hour is equal to 60 minutes, if I say let's take one step backwards here. So let's if I have 2 hours with I've precisely measured that 2 hours. If I want to see how many minutes that's going to be, well, I have two options here. So because 1 hour and 60 minutes are identical, they are the same thing, they're equal to each other, I can multiply my number by it, right? If I were to say I multiply this by 36 over 36, nothing changes, right? It's still the same value. I get 2 hours out at the end. Why would I multiply this? Who knows? Just an example. But the reason this works is because mathematically 36 is equal to 36. I'm multiplying my number by 1, and therefore I'm not changing its value. We're going to see it's going to be the same concept when we're working with units. So because, let me try that again, hours, because 1 hour equals 60 minutes, well, I can go ahead and actually use that equality as a fraction now. Like in the upper one, I use 36 equals 36 as an equality for some reason. That one's not a helpful bit, but this other one could be. How we want to do this is we want to put the unit that we're getting rid of on the opposite side of the fraction. So 2 hours, technically in the numerator, right? If it's just by itself, it's the numerator. So we're going to want to put 1 hour on the bottom of our fraction here. And we're going to put 60 minutes on top. And we're going to see that if we do this math, hours will cancel out with each other. Remember, a unit divided by itself cancels out. And if we go ahead and do the math, we get 120 minutes. Something we knew, right? We already knew if, 1 hour is 60 minutes, then 2 hours is going to be 120 minutes, right? Something we know. But this is a formal way of doing that, using math to demonstrate these things. And this is an obvious conversion, right? It's 2 hours, and so yeah, of course it's 120 minutes. But we're going to see maybe with a year when it's not so obvious. And we're going to take a look at that in just a second. So notice here, I started with 3 sig figs, and I ended with 3 sig figs. So with these unit conversions, thankfully, because we're using defined unit conversion factors, we don't have to worry about the sig figs for those. Those are exact numbers. They're definitions. They're not measurements. Remember, sig figs come from measurements and uncertainty with measurements. So no one, again, 60 minutes is defined as an hour. It's not a measurement. So we don't have to worry about sig figs for those. So kind of we can consider this as having infinite sig figs. So we don't have to worry about it. Take a look at your starting number. It had 3 sig figs. Take a look at your ending number. Make sure it has the same number of sig figs. So that's the idea here. So let's take a look at that example of going from the year into seconds. All right, so we have 1 year. We're going to see if we take a look at our unit plan right here, we had 4 conversion factors that we're using. That's 4 little arrows in between our units. And so we're going to have 4 fractions here. I'm going to make them a little bit smaller so we can have them all fit. So we're going to have 4 fractions here. And thankfully, we've already identified our conversion factors. We saw, the first one we're going to need is between years and days. We already know that one. So that's our first conversion factor, years and days. So if we want to use that here, I'm going to just duplicate it. again, the point of this kind of doing all these fractions is to cancel out units we don't want and to end up with units that we do. So if we want years to go away, we're going to have to put years in the denominator here so that they cancel out. And so we're going to have the other part of our equality on the other side of the fraction. So, and then also notice that I've kept the number with its unit together. So we're keeping all of this. We had 1 year as one part of our equality. We had 365 days. I'm keeping those numbers with those units as we go through this. So we're not going to say 365 years is 1 day. That makes no sense, right? We already, again, thankfully with time units, it's pretty obvious to us. So we don't have to worry about that. So if we just kind of take a moment to look here, we'll see, aha, good. Years will cancel out. That's what we want. We want units we don't want in our final answer to go away. And to do that, we're going to need to divide them. So that'll get rid of years. If we go back up to our plan, our plan says, okay, now we're going from days to hours. Sounds good. We have a conversion factor. Indeed, we do. We've already indicated that that's the second conversion factor we're going to use. 24 hours is 1 day. We currently have days in the numerator. To get rid of it, we're going to need to put days in the denominator. And since we know we're converting into hours, we'll put our hours there. And lo and behold, the days will cancel out. And if we keep on going, we see next in our unit plan, we're going from hours to minutes, and then from minutes into seconds. I'm kind of rushing that because we hopefully are okay with that. And notice again here, your units will cancel out that you don't want. We're going to end up with the unit we do want. So by having it all planned out, we can make it super nice and efficient for us. I'm going to bust out my calculator. I actually found it. Okay, here we go. All right, calculator time. So what's left here? We have 1 year. We have 365, 24, 60, and 60. And thankfully the denominators are all 1. So we don't even have to do any division here. We're just multiplying. So we're going to say 365, technically times 1, but not going to worry about that, times 24, times 60, times 60. And we get our number out. If we go ahead and write all this stuff out, we get... Yeah, I'll use green, why not? There's Oz again, trying to pop his trachea open. Sorry, little dude. He's really old, so got weak cartilage. Okay, anyways. This is our answer, again with the unit of seconds. That's where that S is. Notice we have 4 sig figs in our first number we're starting with. So we're going to want 4 sig figs in our answer. So we're going to keep those. We see, aha, we're going to need to round this. So we'll get 31.54, 1, 2, 3, 4 seconds. Or if you notice this is a really big number, it may be better to put it in scientific notation. Just so it's a little bit easier. 1, 2, 3, 4, 5, 6, 7. So you might say 3.154 times 10 to the 7 seconds. Either of these is okay. Again, the rule of thumb, if it's really big, you'll probably want to put it in scientific notation. But that's a rule of thumb. I'm not going to really go crazy on that. Small numbers, yes. Big numbers are kind of easier for me, but if it's like super small and there's 6 zeros in front, I would please use scientific notation there. So, okay. So, we have our answer rounded to the appropriate number of sig figs. And let's see, does this kind of make sense compared to 1 year? Why did 1 year have 3? Because I said so. So, Michaela, because we're going to see that we're always going to be starting with measurements. So, let's say I have a clock that measures years for some reason. And I started it and then I stopped it again at 1.000 years. And I wanted to see how many seconds I had waited to stop it. It's a weird example, I get it. Though typically, again, if I wanted, I could say, well, what's 2.56 years in seconds? For some reason, I'm interested in that number. In this case, I'm interested in 1 with 3 zeros. If I just gave you 1 year without any significant figures, you're going to end up with 1 sig fig in your answer. And so, because the first number has to be a measurement. So, I wanted to give it some extra significance there. All right, otherwise you would say 3 times 10 to the 7. So, I would always use what I give you. So, I mean, let's take another example. I think that'll make it a little bit more clear. So let's do the same thing and say, okay, well, I have 2.56 years. So I've measured 2.56 years. Or whatever, my magical clock that measures years. If I wanted to find that in seconds, we would do the same thing, right? We would write this all out again. I'm just copying the stuff from above. 60 seconds and 1 minute. If we were to do that, thankfully I just need to multiply this by 2.56. We get 80732160 seconds. We take a look here, we've got 3 sig figs. We want our final answer to have 3 sig figs. So this will be 807.12345 seconds, or 8.07 times 10 to the 7th seconds, either way. So it really just depends on what you're given. So I would not add an extra 0, because if I tell you 2.56 years, that means I have measured 2.56 years. If I have measured 1.000 years, I would not put an extra 0 on that, because then you're changing the significance of the starting value. So unless, I mean, in something like a laboratory setting, you might have a different instrument than me, and so your number might have different sig figs. But since these, I'm giving you all of your numbers, just use the numbers that are given. So just use them with their significance. So, but we see here, we're able to now convert any number of years we want into seconds, following the same plan as before. All right, and so the only thing is you'll need to round your answer to the same number of sig figs that your starting value had, because again, we always start with a measurement. All right, let's do another one. Let's get that going, and then we'll see if we've got some more questions on this process. Let's say we have I've measured my calculator with a ruler, and I get my calculator as, I don't know, 8.21, no, it's bigger than that, 18.21 centimeters. So I have measured this with my ruler. And I want to see how many feet that is. Well, I'm going to give you some conversion factors, and we're going to see what unit plan would make sense here. That's a 12. So, with these two conversion factors, let's see if we can't figure out a plan to change this number from centimeters into feet. Change its unit from centimeters into feet. Well, looking at the conversion factors, we don't have one directly from centimeters to feet, but we do have feet to inches, and we have centimeters to inches. So in this case, I think it makes sense for us to say, okay, let's convert it into inches and then into feet. We'll have kind of that intermediate step of inches there. And so my unit plan, again, this is the unit plan. If we want to think, we already have our conversion factors, I've already given them to us. Whoops. There goes the camera. All right. We know the conversion factors, they're right here. It might be helpful for us to say, okay, we have two arrows in our plan, therefore we need two conversion factors. Let's see which one we should use where. So are we going to use the top one or the bottom one in that first conversion from centimeters to inches? I don't think it makes any sense to use the top one because there's no centimeters in that equality there. So let's keep looking. The second conversion factor has inches and centimeters. And we see, that's exactly what we're doing in our first conversion. So this will be our first conversion factor that we're going to use. And then our second one will be going from inches to feet. So that'll be this top factor here. And so we can say, okay, now we can set this up. We're going to start with our 18.21 centimeters, which I have obtained with a ruler or some sort of length measuring device. Our first conversion factor, as we see here, according to our plan, is going from inches to centimeters. We currently have centimeters, which means centimeters is going to need to be canceled out. So we're going to put centimeters in the bottom, and therefore inches in the top, so that we cancel out the unit we do not want. We don't want centimeters in our final answer, so we need to get rid of it by dividing it. All right, if we're going from inches to feet, again we have our conversion factor. So we have 1 foot and 10 inches, 12 inches rather. So if we want to cancel out inches, because we don't want that unit in our final answer, we're going to need to divide it. So we're going to put the 12 inches on the bottom, the 1 foot on top. And so again here, what we see is that inches will cancel out. We'll be left with feet. That's what we're asked for. We're asked for feet, so we should end with feet. All right, so if we do the math, we're doing 18.21 divided by 2.54 divided by 12. Just so you know, on your calculator, you're going to have to put in the divided sign twice. So just so you're completely familiar with your calculator, how you would enter this, you'd say 18.21 divided by 2.54 divided by 12. So it's important that you put divided each time because your calculator kind of resets the order of operation unless you put parentheses and stuff. So make sure on your calculator you put it this way. You don't do like 2.54 times 12 or something, because it's going to, in fact, then multiply your number by 12 instead of dividing it. So make sure you put it in your calculator like that with 2 division signs. All right, and so the number you get, by the way, is 0.597441, we'll say. Unit is feet. And then the last thing we need to take care of is our sig figs. So we see we had 4 sig figs here. So we're going to need 4 sig figs here. And so our answer with rounding will be 0.5974 feet. So do we see how we did this? We started with centimeters. Our conversion factors that we were given, we had one from feet to inches, one from inches to centimeters. And so we used those to go from centimeters to inches, and then from inches to feet. And we plugged in the numbers, did the math, and we got our answer out. All right. Questions on that one? What shall we have this convert into? Let's ask for... We can ask for meters. That's fine. So, let's do another one. Let's go from millimeters to meters. In fact, let me stop here first, because while I've kind of told you to memorize the chart of your metric prefixes, let me just go over it one time here. So we'll erase this for now. We'll come back to it later. We're going to have an abbreviation plus a base unit. Always, if we're using kind of metric values here, we're going to see that these abbreviations just make it easy to talk about big numbers or small numbers, so that we don't have to have these crazy exponents or something like that, or a lot of zeros. So let's move that out of the way. Okay. The prefixes we're going to be using here are giga, mega, kilo. I'm going to skip hecta and deca because we don't typically use those. We have the base unit. We have deci. These are all prefixes here. Those are all our prefixes. We have centi, milli, micro, and nano. These are the ones I would like you to know. So again, giga to nano here. I'm excluding hecta and deca because they're not very common. But how these work is giga is a prefix, meaning it's 10 to the 9th power times bigger than your base unit. So if we say we have one, by the way, the abbreviation for this, G, capital M, lowercase k, D, C, M, mu. It's a Greek letter there. Looks like kind of a U with the long starting part, and then nano is N. We're going to see that 1 10 to the 9th, let's say liters, some base unit, is equal to 1 giga liter. So 10 to the ninth of something, whatever that unit happens to be, is the same thing as 1 giga of that unit. You could say in the same sense, 10 to the ninth meters is 1 gigameter. It's a way of talking about these things. So the powers of 10 we're going to have to deal with here are 10 to the ninth, 10 to the sixth, 10 to the third, our base unit, whatever that happens to be, 10 to the minus 1, minus 3, minus 6, minus 9. Again, there's a chart in Discord that has all of this in there. But these things are just going to tell us what exponent to use. So we're going to have all of our conversion factors set up. And it's going to make things easier for us this way. If I wanted to say, okay, I have a megagram, capital M, lowercase g, g for gram, I would say, aha, well, that's just 10 to the sixth grams. We're going to see that your one of your prefix units, whatever, if you're using nano, micro, giga, whatever your prefix and unit are, is equal to that exponent times your base unit. And so we might say, okay, well, 1 nanowatt, whatever, is equal to 10 to the minus 9 watts, for example. Or we might say 1 microjoule is 10 to the minus 6 joules. Absolutely. 1 gigabyte equals 10 to the 9th bytes. One mega, let's see something else. 1 centi, what unit haven't we used yet? Centi, whatever, we'll do some meters, is 10 to the minus 2 meters. So it's always one, just one, of whatever your prefix and unit are. And you're going to take that power of 10 from this chart, and that's how many of the base unit you have. All right, so your base units, again, we see super common ones: liters, meters, grams, seconds, watts, joules, calories. We'll see moles later on. We'll have, I don't know, what other units do we deal with, really? Bytes, sure, but yeah, whatever. These are common units. Base units. And the beauty of the metric system is it allows us to talk about really big or really small things with easy numbers. So instead of saying, okay, yes, my processor is 4.6 gigahertz, right? Without that prefix there, that would mean 4.6 times 10 to the 9th hertz, right? Or if we were terrible people, without the unit, without the kind of prefix there, we would have to write this number out. How awful is that? It's terrible. It's a pain. But these prefixes allow us to say, I like this number. I don't have to have a lot of zeros. I don't have to have this power of 10. It's very easy for me to talk about this 4.6 gigahertz without having to count, okay, how many zeros are there and deal with that. So the purpose of these prefixes is to make it very easy for us to talk about very big or very small quantities. And so, a higher end processor is going to have, a frequency, an operating frequency of roughly this number. And, it's easier for us to compare. We've got 4.6 gigahertz versus 5.1 gigahertz or whatever. It's just easy for us to think about those numbers if they have the appropriate unit with them. And so it's just easier to talk about really big numbers, for example, with giga. Another example is, we see light between about 400 to 700 nanometers. That's about visible light. That's how long the light waves are in one segment. We'll talk about that later on. If we were to do it otherwise, though, we'd say 0, 0, 0, 0, 0, 0. How many zeros is this going to be? 4 meters. Like, it really is quite silly to say, okay, well, look at this number. It's a pain, right? Nobody wants to write those zeros. Nobody wants to read those zeros. But it's easier for us to say, 400 nanometers. Got it. A little bit easier for us to kind of handle mentally. So we're going to see that these conversions, or we're seeing that these units are going to be very useful for us. So let's go ahead and take a look at that one that we had before. I had asked for this, right? Well, since this is metric, we're going from millimeters to meters. That's millimeters. So all your little prefixes here, these letters at the start of a different unit, tell you the prefix that's associated with it. So that M, that first M stands for milli. So this is millimeters. This one is just meters. One letter is a base unit, or sometimes several, like calories has 3 letters as its abbreviation. You need one more letter to put the prefix on, right? So we could have centimeters, or kilometers, or gigameters. There's no problem with any of those. So let's go ahead and see how this is going to work. Thankfully for us, this is just one step. We know that 1 millimeter, if we look at our chart, 1 milli something is 10 to the negative 3 somethings. So 1 millimeter is 10 to the negative 3 meters. This is, by the way, this is the way I'm always going to do it. I'm going to follow this chart exactly, always putting 1 prefix unit equals 10 to the whatever base unit. That's how I will always do it. However, some of you, if you've learned this before, is saying, oh, well, we have 1,000 millimeters in 1 meter. That's fine. Go ahead and use that. They're mathematically equivalent, right? These two say the same thing. 10 to the third millimeters is 1 meter. It's the same exact thing as saying this. However, this is the way I'm going to be using it in the class. I'm going to be consistent with this way, but if you are comfortable using an equivalent but different number, go right ahead. No problem there. So, with this in mind, our unit plan is just one step, thankfully. And so, we only need that one conversion factor. Let's go ahead and do it. So, our conversion factor has 1 millimeter and 10 to the negative 3 meters. So, we're going to put millimeters in the bottom so that they cancel out. And we're going to put 10 to the negative 3 meters. Again, I'm keeping all the numbers together. So 1 millimeter goes here, 10 to the negative 3 meter goes there. And we end up with 2.24 meters once we do this math. All right. Hopefully that's okay. Let's do another one. Let's say I've got oops. Here's another one. 82,920 centiwatts is how many microwatts? Don't forget that symbol in front of watts there is micro. Centi and micro here. With those, well, we might say, okay, I have some conversion factors that I can use. I know that 1 centiwatt is 10 to the minus 2 watts. That's from our metric chart. And I also know 1 microwatt is 10 to the minus 6 watts. So, just by putting kind of our definitions out there, we can see, we now have kind of this good middle ground to step over in between centiwatts and microwatts. And that would just be plain old base unit watts. So a unit plan for this might be centiwatts, starting with centiwatts, going to watts, going to microwatts. Just looking at our conversion factors that we have, I'm just like saying, okay, well, I have centi, I have micro, let me just put out the definitions of those, and poof, now we have 2 conversion factors. And we see here that both of these have a watt. Both these conversion factors have watts in them. So it would make sense for us to use watts as the kind of middle part of this conversion. So we're going to need 2 conversion factors because we have 2 arrows in our plan. The first one, we want something between centiwatts and watts, which we have. That's our first one. And we have our second one here that we're going to use. So now that we have our plan and our factors, we can go ahead and throw this out here. Remember, since we have centiwatts already, we want to get rid of it. We're going to put 1 centiwatt on the bottom, 10 to the minus 2 watts on top. Now we need to get rid of watts, so we're going to put watts on the bottom. And we're going to put microwatts on top. And so all we need to do is this math. This hopefully we can do without a calculator. The 10 to the minus 2 and the 10 to the minus 6 together become 10 to the minus 4. I'm sorry, 10 to the positive 4. So we're going to end up with a pretty big number here. Hopefully we see that. Remember, for powers of 10, remember last time we talked about if we multiply them, we add them together. If we divide them, we're going to subtract them. So minus 2 minus minus 6 is positive 4. So we would say 82920 and then 4 more zeros. Microwatts. Totally I guess it's okay to write it this way. Or you could say, okay, well, that 82,920 times 10 to the 4 microwatts, that's technically okay too. It's a little bit bizarre because it's not quite scientific notation. It's just, well, I've taken my base number and multiplied it by 10 to the 4th. I mean, that's a little bit less okay. Um, Technically, mathematically, it's okay, though. But it's better to either have it completely in standard notation or scientific notation. It's not really the best to have it this kind of halfway done one. And so with this, we're going to get 8.292 times 10 to the 8th microwatts. That would work. So notice I'm moving it 1, 2, 3, 4. And so 4 plus 4 there is going to be 8. So either one of these would be okay. But again, because this is such a big number, it's probably easier to use the scientific notation one. All right. Any questions on that one? All right. Let's go ahead. Let's do another one. Let's take our 4.6 gigahertz. So, what's the rule in dividing exponents? Okay, so that's our rule for exponents. So if you have 10 to the x divided by 10 to the y, you subtract the two of them in your answer. So if it's, for example, 10 to the 5th over 10 to the 6th, that equals 10 to the minus 1. So you just subtract them. And if you had the other way, you'd add them if you're multiplying. Okay, so let me actually move this down a little bit. All right, a little bit less intuitive, this next one. Yep, no problem, no problem. One thing that you don't know yet, 1 hertz is the same thing as 1 inverse second, so second to the negative 1 power. So that is something, it's so hertz means like per second, essentially. So typically, I mean, this 4.6, I put it in the context of a processor. That's saying it does 4.6 giga calculations per second. That's what that typically means for this. Or it could be something like rotations per minute. That could be given in hertz as well. Something per time. And so that's something to use here. So, another way of saying this, though, is 1 over second. So remember, a negative exponent just means 1 over that number. Let's see if we can't work with this. So I'm asking it for minutes to the negative 1 power. That's the same thing as saying 1 over minute. So I've told you that 1 hertz is 1 over seconds. Let's see if we can't figure out some conversion factors here. So I'm giving you this one. Those two say the same thing, by the way. Second to the negative 1 power is the same as 1 over seconds. Let's think what we might need in terms of plan here. gigahertz is what we're starting with. We're ending up with 1 over minute, or minute to the negative 1 power. Those are the same. Let's think how we might do this. Well, if nothing else, if you're really stuck on making a unit plan, it's a good idea to just put out conversion factors that you do know and try and see if there's going to be any connection between those and ones you're given. So we might be like, okay, well, I have no idea where to go from this. But I do see that I'm given a metric prefix in one of mine. So I might as well, let me write out what that prefix means. I might be like, oh, right, 1 gigahertz is 10 to the 9th hertz. That's hopefully something we're okay with. And so now we have, okay, well, look, we've got, in our conversion factors, we have this hertz idea. We have gigahertz, we have hertz. But I've been given hertz to seconds. So that's something that's also useful there. And then the last thing we're going to be given is minutes, right? And we're like, that's right. I know that 1 minute is 60 seconds. And so now we'll be like, aha, I now have, now that I've written out kind of some definitions in terms of unit conversion factors, we might see, okay, now I've got something from gigahertz to hertz, I've got hertz to seconds, and minute to seconds. Aha. That tells me, okay, now I have enough to go through this, right? I'm going to use minutes to the negative 1, by the way, for this. I think it'll be just a little bit easier. So, we have a conversion to take us from gigahertz to hertz. And we have a definition of hertz to seconds. And then, we can go from seconds to minutes. What's good to know here is that if this minute to seconds thing is true, we can just say, I'm going to put a 1 over both of those. Well, technically it's 1/60th, but we'll get there. Let's leave it as it is for right now, and see if we can use it this way. So let's go ahead and identify our conversion factors. So first things first, we'll have gigahertz to hertz. That's our first step here. Hertz to second to inverse seconds. We can use either of these. I'll just put a 2 here because we can use either one. And then we have our seconds to minutes idea. Alrighty, let's take a look. Let's see if we can't just work through this. So we're starting with 4.6 gigahertz. Our first conversion factor we're using is going from gigahertz to regular hertz. We're going to put gigahertz on the bottom so that it cancels out. And we're going to put 10 to the 9th hertz up top. So gigahertz cancels out. And then we can say, okay, well, we can say, okay, we've got this 1 hertz equals 1 over seconds, or second inverse. You can use either one. Anybody have a preference? It'll be the same either way. In either case, hertz is going to go on the bottom, right? We'll use this one. All right, so again, we have this idea of the, our third conversion there is regular minutes to regular seconds. But we need the inverse of that, right, to the -1 power. So again, if we're going to put this to the -1 power, mess with our conversion factor a little bit, we can do that. Or we can just put seconds in the denominator. Either way, let's take a look at it both ways. I'm going to copy this. We're going to do it both ways. Move it a little bit to the side. Okay. If we say, okay, well, this minutes and seconds business needs to be inverted, well, we can just, let's go ahead and put it in. And we're going to have to put that to the -1 power. -1 power means we're just going to flip it over, right? But the problem here is that if we flip it over, we're going to end up with second inverse in the top, right? If we just take this, sorry, I have to do all this like math rules again. We're going to end up with all this fun, good stuff here. 1 minute to the -1 power. It's a pain, right? It's a lot of fractions within fractions. It's kind of scary. So what we might want to do is be like, okay, well, I know 1 second to the -1 power is the same thing as putting that second down here. You just move it down. And then we might be like, aha. Now I can put in my normal conversion factor. And we're going to see here, let's just see what happens. So we see gigahertz cancels, hertz cancels, seconds will cancel because now we have it in the opposite side here. So it's, if we take that inverse seconds and just move it down, it's going to be a lot easier than trying to have to do this inverse business. And notice that now we can put seconds in the numerator to cancel it out. And we're going to end up with minutes in the denominator. Minutes in the denominator, remember, is our inverse minutes. And so we'll end up with the correct unit this way. A little bit easier to just move your seconds down. Move it down to the denominator. So again, what I did, we had an inverse unit here. I said, okay, well, that's a little bit hard to use. So I got rid of it by moving it to the denominator, right? Inverse of a unit is the same thing as 1 over the unit. So I just moved it to the denominator. And then it made the rest of it not so bad, because now that I have seconds in the denominator, I could put, yes. I mean, if I really wanted to, I could do it with a positive one. I could say, okay, I'm getting rid of this, and now it's minute to the -1. Totally okay to do that. Right? So if I say x squared, I could say that's 1 over x to the -2 power. Totally okay to do this anytime. It doesn't really make sense most of the time to do it, but you could. I can take a positive exponent and make it negative and now put it in the bottom. So just remember your kind of exponent rules here. So um, a negative exponent is the same thing as saying 1 over the positive exponent. So again, x to the negative 3 is the same thing as saying 1 over x cubed. So couldn't work either way. But we typically like things with positive exponents, right? So typically, I think you could totally do this other one with the minutes, but I think it's a little bit easier to not do it. So just kind of reminding you of your exponent rules here. A little bit more complicated of a problem. So just don't forget standard math rules apply here. So if you want to move units, you can. If you want to combine conversion factors, you can. Say, instead of ask for minutes, I ask for hours. You could say, well, I know 3,600 seconds is an hour. I don't need to go to minutes in between. So as long as things are mathematically okay, you can do whatever you want. Whichever way kind of makes the most sense to you. So I think here it's going to be a little bit easier to say, okay, well, I can just move this second business down so that it can cancel out more easily. And if we do this, by the way, we can do our math. If we do this, we get basically 4.6 times 10 to the 9th times 60, which is 276 times 10 to the 9th. Inverse minutes, or per minute. We could leave it as that. I'll just do it here. That would work. You could leave it as divided by minute, or you could put minute to the negative 1 power. Either of those are okay. I put one in scientific notation. I left one kind of as is. Again, though, technically either of these are correct. So you could also say, if you really wanted, 2.76 times 10 to the 11th minute to the negative 1. That's great, too. That's probably the one I would do at the end there. But, again, any of these will work. So just don't forget your kind of just fraction rules in general. So here, we can do a little bit of a summary here. So fraction rules. Anything divided by itself equals 1. Right? So, for example, centimeters over centimeters, they just cancel out. So, cancels out. If we say anything multiplied that becomes an exponent. So for example, if I have meters times meters times meters, that's meters cubed, cubic meters. With exponent rules, so that again, we could say anything raised to a power is the same thing as 1 over something raised to that negative power. Or x to the minus 3 is 1 over x cubed. Either way these work. Remember that 10 to the x over 10 to the y equals 10 to the x minus y. 10 to the x times 10 to the y equals 10 to the x plus y. Any other rules that we need to put in here? I don't think so. I think we're good. So kind of just remember these mathematical principles here as well. So they'll all be important for us. All right, we have 15 minutes left. I'm going to kind of have to start moving a little more quickly in these last couple of examples here, just to make sure that we can cover it so I can have us move forward. So, let's say, what about units raised to powers? For example, I could say this room that I'm in is let's see, I don't know, 80 square feet. Here, and I'll even say 80.0. If I wanted to say how many that is in square inches, we could do that. We're going to see that, we know 1 foot is 12 inches. But how do we go from square feet to square inches? Can we just do this? We do this, let's see what we get. What kind of unit is this? Remember, for exponents, we get rid of the square. That cancels with the feet on the bottom. So we're left with feet times inches, which is a unit that totally does not make sense. But we could just do it again. We're going to say, that 960 inches times feet. Well, let's just do it again. This time, our feet cancel out. And we get now inches times inches. So inches squared. With sig figs we need 3, so that would be with sig figs there. Notice we had to do it twice. Had to use the conversion factor twice for square units. And guess what? For cubic units, you'd need it 3 times to cancel everything out. Alternatively, though, we saw that 1 foot is 12 inches. We can totally just square everything here and say, well, 1 square foot is 144 square inches. And then we can just use this as a conversion factor. If we do that, we should get the same number at the end. So feet squared cancel with feet squared. We're left with inches squared, and we have our answer. So, because we would have to use this conversion factor twice, because we had square units, we could just square our conversion factor instead, and just do it in one step. Either way is fine. I think I prefer the second way, because you have less fractions to deal with then. But either way you like, you are welcome to do it. And so you would just need to square your conversion factor or cube it or whatever. Just throwing another one here. If we had here, that many there. Here, we'll say meters squared. And we have, I'm going to just give you these conversion factors. The first one I don't expect you to memorize. I will provide that for you if you need it. This one, though, I would expect you to memorize. That's a metric prefix. You'll want to learn those. So don't worry about anything besides memorizing metric prefixes as your unit conversion factors. So everything else I will give you. Okay, so if you want to do this, plan it out. We see that we're going to have centimeters squared as our kind of intermediate. Since all of these are, in fact, let's use cubic ones, because why not? If we have cubic units, it may make sense to just cube our conversion factors. Since all of these are going to need to be cubic units, inches cubed, centimeters cubed, meters cubed, we can see, aha, well, 1 inch cubed is 16.387 centimeters cubed. Hooray. And then 1 centimeters cubed is 10 to the minus 6th meters cubed. And now we can use those. Again, I'm going to kind of go quickly through this, but it's really the same idea. So if you've got square units, you'll want to square your conversion factors. If you've got cubic units, you'll want to cube your conversion factors as necessary. So 1250 inches cubed times 1 inch cubed. I'm using these two conversion factors. 16.387 centimeters cubed. Centimeters cubed now goes on the bottom. Do this fun stuff. That number times 1250 times, well, I guess I don't need the times 10 to the 6th. I get 0.205 meters cubed. Oops, that's a cube. And so that's what we would get there. So just cube your conversion factors as necessary. All right, so make sure that you're using the correct conversion factors. Again, if you really wanted, do it 3 times each, or you can just have the cubed part. So I think it's a little bit easier there. Just so we know where this number came from. This number here is 2.54 cubed. So that's where that number came from. All right. Last little bit here. Let's say I have a complex unit, 2 units in 1, miles per gallon, and I want this in feet per feet per quart. It's a bizarre unit, but why not? This is a question I've given you. We can do this. I'm going to give you some conversion factor here. 1780 yards is 1 mile. 3 feet is 1 yard. 1 gallon is 4 quarts. We can do this. Planning it out, we're starting with miles per gallon. We have 2 things to change here, and we can do them in either order. We can either change the top unit first, get that into feet, or we can change the bottom unit first. It really doesn't matter. With multiplication and division, it, there's a commutative, or I think commutative property, like A times B times C is A times C times B. Like, you can rearrange it and it's all the same. I'm going to decide to change the bottom unit first, because why not? You could choose the other one. Well, gallons to quarts we have. We have a conversion factor there. So we can. The top unit's going to stay the same, but I can change the bottom unit to quarts. And we'll go ahead and see what that's going to look like. And then now I can mess with the top unit because the bottom unit's done. We have the denominator that we want. Well, looks like here we have another intermediate unit. We don't have something directly miles to feet, but we do have miles to yards and yards to feet. So we're going to use yards in the middle. Our bottom unit this time doesn't change. And then now we can go to feet per quart as well. Looking at our conversion factors, if I wanted to do gallons to quarts first, that's my first conversion factor. The second part I'm going from miles to yards, so that's going to be this one. And the third one is going to go from yards to feet, so we're going to use that one third. So 1, 2, 3. Let's take a look. 47.2 miles per gallon. If we want to do gallons to quarts first, we can. Note that because gallons is in the denominator, we want that to go away. So we are going to put gallons on the numerator so that they cancel out. We don't want gallons in our final answer, so we're going to put it in the opposite side to get rid of it. And here we have 4 quarts. So here, gallons cancels out. Hooray. We now have miles per quart. We have 2 minutes left. Let's get through the last little bit here. Now we have, our bottom unit is where we want it, so we're not gonna mess with quarts anymore. We have miles. We want yards. We have our conversion factor. 1 mile, 1780 yards. Miles cancels out. We're currently now in yards per quart. Almost there. One more conversion factor. 3 feet up top. And now we have it. We've canceled out yards. We are left with feet divided by quarts. That's the unit I asked for. So we are in good shape. Now we just plug and chug. So 47.2 divided by 4 times 1780 times 3. Again, ignoring all those ones because we don't need them. And we get 6302, 12 yards per quart. And looks like we need 3 sig figs on that. So we're going to have to put this one in scientific notation. Hooray. We have got our very bizarre unit, but there it is. So, awesome. All right. Finished just in time. For 101 students, we are going to continue with this idea at 8 o'clock on Tuesday morning. Hopefully I'll wake up. For 111 students, we are going to move on. So you'll want to really practice this if you're in 111. You're going to have the worksheet. You're going to have another worksheet that I'm going to post later today that you'll have due next Thursday. So you'll want to get started on that. It's on this dimensional analysis idea. Last thing, our Discord post for the week. for week 2 is say something you find, whoopsies, interesting involving chemistry. You're going to write that in your general tab of your class. Something interesting involving chemistry. So say you are you like to cook. You can talk about how you like cooking and how, just very briefly, about how chemistry is involved there and how it's reactions of different molecules coming together to, give you tasty Maillard reactions or whatever. Or you like fireworks and you like how, different ingredients give you different colors or different explosion patterns. Or you like makeup and you find it a pain that your makeup turns orange because there's iron in it that oxidizes at the end of the day. Whatever. Something you find interesting involving chemistry, that's what you're going to write this week for your thing. Just a sentence or two. It does not have to be long. Just something you find interesting that involves chemistry. And again, you're going to see that since chemistry is all about matter and everything is matter, it's going to be anything you want. So, but try and, have something to do with something you understand maybe a little bit about chemistry. So, all right. Cool. I will see you then. Enjoy your weekend. Happy Labor Day. We'll have another stream on Tuesday. So again, look later today for another homework assignment. So on dimensional analysis. So we'll go from there. Okay. Awesome. Take care, everyone.